The famous old town of Kurashiki in southern Japan is the location of the Okayama factory of the Union Die Casting Company Limited. This is a small plant employing just 15 people. They are involved in die casting and machine processing of parts for their client company, a maker of small-size motors on the island of Shikoku, about 50 kilometers away. A key feature of the production process and delivery system here is the Kanban system. But how does such a small plant manage to operate a Kanban system? It actually represents the fruits of 3 years of joint effort between the companies, particularly by Mr. Kozai, in charge of outside orders at the client company, and Mr. Goda, the factory manager of Union Die Casting. These are actual Kanban, essential for realizing the full Kanban production and delivery system. In Volume 3, we would like to take a look at exactly how the Kanban system works, taking the movement of products between the two factories as our case study. Let's take a look at the various Kanban used here to support the delivery system between the two factories. The main role for the Kanban here is as a tool to complete the process of withdrawal of parts by the subsequent process. The Kanban can be made freely according to the purpose and contents. Let's take a look at the three main functions of Kanban. The first is their function as stock sheets. The idea of Kanban originally came from clear labeling of a box of parts to ensure that you are never out of stock. The Kanban clarifies exactly what is contained and how much. Kanban also serve to give instructions with regard to transportation. Whenever an item is being moved, it must have a Kanban attached. This is because there should never be any difference between the number shown on the Kanban and the number actually inside, and also because a Kanban clearly indicates the destination. For outsource items, the Kanban should also show the delivery cycle. The third function of Kanban is to serve as a sheet for production instructions. When the Kanban is removed, production begins. The removal of the Kanban signifies that the subsequent process is using stock, and the preceding process can start immediately to produce the amount instructed by the Kanban, in line with the principle of producing only the quantity that has been withdrawn. The Kanban system is a control process, which does away with the need for a production plan as such. Let's follow the delivery procedure, focusing on the Kanban flow. Twice a day, products from the Okayama factory are taken across the Seto Bridge over the inland sea for delivery to the client company's plant in Takamatsu. This is how the Kanban moves inside the client company warehouse. Parts required by the assembly line are taken out, and the Kanban is removed and put in a special Kanban mailbox. Twice a day, all the Kanban from the Kanban mailbox are moved to the order box for sorting, and delivery instructions are made to the Okayama factory. Because the delivery cycle between the two factories is very short, instructions for the next delivery are made by fax in advance. Now we're back at the Okayama factory. Let's look at the cycle of the processing Kanban used here. Once the delivery instruction fax has been received, the corresponding items are taken out from the finished product store. As soon as the products are moved out, the processing Kanban are removed and put in the order box. Twice a day, the processing Kanban from the box are taken to the order board and used as instructions for NC processing. According to the Kanban instructions, items are taken from the outsource order item store to the U lines for NC processing. When processing is completed, they are delivered to the finished product store with the Kanban attached. Now let's take a look at the cycle for outsource order Kanbans. When the items are taken for NC processing, the Kanban are removed and put in the Kanban mailbox. They are then sorted out and put in the order box to give instructions for outsource order processing. Casting work is then taken from the die-cast store according to instructions from the Kanban for delivery to the plant doing outsource order processing. After annealing, anti-rusting and coating, the workpieces are delivered back to the outsource order store with Kanban attached. Next, the cycle for materials Kanban. When die-cast workpieces are removed for outsource order processing, the materials Kanban are removed and put in the Kanban mailbox. They are sorted out at the order box and served to give die casting instructions. Materials are taken for casting from the materials store according to the Kanban instructions. die casting is completed, they are taken to the die cast store. Next, the cycle for raw materials Kanban. Put simply, raw materials Kanban indicate the need for ordering. When raw materials decrease towards the point of ordering, the raw materials Kanban is taken to the order board to indicate the necessary order. The order is placed according to the information on the Kanban. When the raw materials are delivered, the Kanban is returned to the place where the order came from. As we have seen, the Kanban cycles are controlled by the activity of the subsequent process. This is a good example of so-called pull production, and is the way both Kanban production at the Okayama factory and Kanban delivery to the client company are controlled. We've seen the Kanban system in action. Now let's see just how they set up the system. This graph indicates the quality improvements at the Okayama factory. It shows that originally they were far away from the basic Kanban principle of complete delivery of 100% perfect goods within the designated delivery date. At that time, they were listed as one of the worst 10 companies amongst the client company's parts suppliers. The factory manager, Mr. Goda, realized that there was an urgent need to devise a counterplan to avoid defects. Helped by Mr. Kozai from the client company, he started investigating the reality of the situation in order to work towards zero defects. After investigation, they tallied up all the defects they found. During this process, it became clear that the operators didn't have any clear standards for judging defects. Mr. Goda was very surprised and disappointed to discover just how far-reaching the occurrence of defects was in reality. However, Mr. Kozai was optimistic that they will be able to find solutions to all the problems. Following Mr. Kozai's advice, Mr. Goda decided they would have to set up an anti-defects plan throughout the factory, involving everybody. He announced his plan to the whole staff, saying that he was sure they could make progress with everyone's combined efforts. Everyone soon got involved in the process of getting rid of the causes of the defects. Their aim, zero defects. And then one day, Mr. Goda suddenly had a flash of inspiration about the way they should proceed towards zero defects. His inspiration was to use the key word immediately. For example, when a piece is cast, treat it immediately. Then process the treated item immediately. And give the finishing touches and inspection immediately. Then the product can be delivered immediately. This is a concept of zero stagnation. Mr. Goda's inspiration was the key to beginning examination of just how they could create a production flow suitable for immediate action. The vital point was to establish a flow suitable for subsequent process control via the Kanban system. They decided that two basic pillars for this were needed: U-lines for immediate processing and a central flow market. Mr. Goda discussed with Mr. Fujimoto, section leader in the manufacturing section, how they could create U-lines for the machine processing process. This was the layout before improvement. As you can see, a straight line layout was used, with one operator allocated to each of the 4 NC lathes and 2 operators at the drilling and tapping machines. They discovered that at the NC lathes, the operators had to spend most of the processing time just watching the machines. With that layout, Mr. Goda's immediate action ideas could never be realized. So they decided to try a change from the present straight line to a U-line. A model line was set up, and Mr. Fujimoto himself tried it out, both to make sure it worked, and also so that he would be able to train the others with full hands-on working knowledge. Then one of the regular operators was asked to try it and see if there were any more ideas for improvement. They then drew up a combination standard worksheet. By observing both the actual working time and walking time taken from the start to the end of the U-line, and combining the figures with the automatic processing time taken by the NC lathe. After a great deal of trial and error, they developed this new layout, which had some changes made in the processing order. The punching and tapping processes can now be done simultaneously. The work is then put into the NC lathe immediately, and the previous work removed for immediate cleaning and measurement inspection. The work is put straight into the delivery box, and another work received from the preceding process is taken out for punching and tapping.
The tables for the drilling and the tapping used to be separate. Now we have a U-line and we can work on 2 items at the same time. 2 tables have become 1, so it takes less time. That means we have more time to check for defects. In fact, we have now managed to get down to 0 defects.
The creation of these U-lines for immediate processing also had the effect of reducing the necessary workforce from 6 operators down to 4. The next step was to set up a central flow market. which is a vital part of the Kanban delivery system. The idea of a flow market is to reduce the size of the base for both Kanban production and Kanban delivery by reducing the stock of finished products in store by 50%. There were 4 basic points behind the setup of the flow market at the Okayama factory. The first point was to establish a concrete purpose. The target agreed upon was to maintain strict observance of a 100% prompt delivery rate in order to avoid giving trouble to customers. The second point was to decide on a launching pad for improvements. They fixed on the improvement of delivery boxes. They decided to minimize the size of delivery boxes to make them more manageable and suitable for small lots. They designed new boxes for 40 items, 30 items, and even as small as 10 items. The third point was to observe the movement of stock. The fourth point was to establish control standards for the central flow market. The standards set were full work and no work. When the stock becomes full work, processing is stopped. When it reaches the no work standard, processing is started to compensate for work required by the subsequent process. Through meeting the difficult challenges of how to reduce stock and maintain observance of a 100% prompt delivery rate, they succeeded in achieving a 77% reduction in the stock of the popular PX models. The rate of punctual delivery, which used to be around 80 to 90%, shot up to a consistent 100% as a result of the improvements. We've seen how the improvements in the production flow adjusted to subsequent processing, which is vital as a base for full Kanban utilization, were implemented at the Okayama factory of the Union Die Casting Company. There are, of course, many more areas to be improved, including die standardization, chip removal methods, and setup time. But the staff here now have confidence to tackle all of these, based on the knowledge that the 15 of them working together have already managed to develop successful Kanban production and Kanban delivery systems. Just in time and on time, every time, with TPS.